In the early 1990s, residents of Southern California began reporting something strange. Without warning, deafening sounds tore through the sky. Sharp concussive booms powerful enough to rattle windows, shatter glass, and set off car alarms across entire neighborhoods. Emergency lines lit up. People rushed outside, convinced a plane had crashed or an explosion had occurred. But nothing was there. These were not rolling thunderclaps or the familiar cracks of supersonic fighter jets. Witnesses described the sounds as heavier, deeper, more violent, almost unnatural. Some compared them to artillery. Others said it felt like the sky itself had split open. Around the same time, grainy photographs began circulating. Dark triangular shapes were spotted at extreme altitude, too high and too fast to be conventional aircraft. Some images showed little more than black silhouettes against pale skies. Others captured faint shock diamonds or oddly shaped contrails. The photographs were inconclusive, but the timing was impossible to ignore. Behind the scenes, something else was happening. Billions of dollars were quietly flowing into the U.S. defense budget under a deliberately vague category. Black programs. No public descriptions. No hearings. No accountability. Just unexplained allocations that appeared, shifted, and vanished from one fiscal year to the next. To skeptics, these events were coincidences. Sonic booms happen. Photos can be misleading. Defense budgets are complicated, but to others, the pattern was unmistakable. They believed it pointed to a secret project, one that had been officially denied for decades. They called it Aurora. As the years passed and technology advanced, the reasons such an aircraft couldn't exist steadily disappeared. Materials science improved. Computer modeling revolutionized aerodynamics. Hypersonic research accelerated quietly inside classified programs. And behind layers of denial and disinformation, a stubborn possibility remained. What if the biggest mistake people made about Aurora wasn't believing it existed, but assuming it couldn't? Because if you want to know whether a hypersonic aircraft could fly in total secrecy, the real question isn't how advanced the technology was. It's how the United States hides entire aircraft programs in plain sight. To understand how Aurora could exist, you have to understand the Pentagon's black world. Contrary to popular belief, it isn't a single shadowy organization. It's a sprawling, classified ecosystem spanning the Air Force, Navy, intelligence agencies, defense contractors, and private research laboratories. Programs are compartmentalized, funding is fragmented, and even senior officials often see only a small piece of the whole. The true scale of this system is hinted at through cryptic budget documents, where classified programs appear only as code names, vague descriptions, and unexplained dollar figures. By the early 1990s, the U.S. black budget had ballooned to nearly $16 billion, accounting for roughly 17% of all Pentagon research and procurement spending. To put that into perspective, that figure exceeded the entire defense budgets of many allied nations at the time, and almost none of it could be publicly explained. The designation Aurora first appeared in a 1985 Pentagon budget document, buried in a single line item for $455 million, listed under procurement for a stealth reconnaissance aircraft. The following year, the line item vanished, replaced by funding under a different name. To budget analysts, this pattern was familiar. It's how the Pentagon conceals major classified programs, by rotating designations and distributing funding across multiple categories. What made Aurora different were the amounts involved. Some estimates suggest cumulative spending exceeded $10 billion by the late 1980s. For comparison, the entire B-2 stealth bomber program cost roughly $44 billion for just 20 aircraft. That money had to be going somewhere. Historically, America's most secret aircraft share one thing in common. They are tested far from prying eyes. Nearly all classified flight testing has taken place at Groom Lake, better known as Area 51. Beyond its warning signs and restricted airspace lies something that puzzled analysts for decades: a 6-mile-long runway, more than twice the length of standard Air Force runways. Such length would only be necessary for aircraft with unusually high takeoff or landing speeds. Satellite imagery from the 1990s showed repeated resurfacing with heat-resistant materials, consistent with extreme thermal loads. Former Area 51 workers later described climate-controlled, hermetically sealed shelters. Structures designed to house vehicles requiring precise environmental conditions. One contractor described them as closer to spacecraft storage than aircraft hangars. Whatever was being tested, there wasn't just fast. It was exotic. Officially, the Air Force insists no hypersonic spy plane is hidden in the Nevada desert. But in June 1991, something happened that challenged that claim. A massive sonic boom thundered across Southern California. The shockwave was so intense that emergency services were flooded with calls. Many residents initially believed an earthquake had struck. Seismologists were brought in, and they confirmed something startling. This was not a natural event. The seismic data showed vibrations consistent with an object traveling between Mach 3 and Mach 4, far faster than any commercial aircraft and beyond the capability of most military jets. The space shuttle was briefly considered, then ruled out. No re-entries occurred on those dates. The SR-71 Blackbird was another possibility, but it had been officially retired. The shockwaves traced a path northeast, over Los Angeles, across the Mojave Desert, toward Nellis Air Force Base, one of the most heavily instrumented test ranges in the world. But what made the booms truly unusual was their pattern. Witnesses described them as rhythmic, almost pulsing. Analysts suggested a possible explanation: pulse detonation engines, a propulsion system that generates thrust through rapid controlled explosions rather than continuous combustion. Pulse detonation engines offer enormous thrust and efficiency across wide speed ranges, making them theoretically ideal for hypersonic flight. But they come with a major drawback: noise. Tremendous, earth-shaking noise. If Aurora used pulse detonation propulsion, it would explain why the sonic booms were so violent, so distinctive, and why they occurred during carefully selected nighttime testing windows. And the booms didn't stop in 1991. Similar seismic signatures appeared sporadically throughout the 1990s, always following similar paths, always officially unexplained. By the late 1980s, rumors were already circulating. In 1988, the New York Times reported that the Air Force was developing a Mach 6 stealth aircraft. 2 years later, Aviation Week described a mysterious aircraft regularly departing Edwards Air Force Base late at night. One eyewitness even claimed to have watched it cross 400 miles in just 6 minutes over the Pacific Ocean, an average speed well beyond Mach 5. And the sightings weren't limited to the United States. In 1992, residents near RAF Machrihanish in Scotland reported an overwhelming noise unlike anything they had ever heard. No aircraft were visible. The base had an unusually long runway and direct access to the North Atlantic, an ideal forward location for a secret hypersonic platform. That same year, strange donut-on-a-string contrails appeared over Texas, then over Scotland just days later. Atmospheric scientists noted that they formed at altitudes exceeding 80,000 feet, far above commercial traffic and most military aircraft. If the same platform appeared over Texas and Scotland within days, it suggested global range capability. At hypersonic speeds, crossing the Atlantic could take less than 2 hours. One of the most compelling eyewitness accounts came from Chris Gibson, a former member of Britain's Royal Observer Corps. In 1989, while working on an oil rig in the North Sea, Gibson observed 2 F-111 fighters refueling mid-air. They weren't alone. Flying with them was an unknown triangular aircraft, larger than the fighters, with sharply swept edges and a blended body. Even more astonishing, it was also refueling. Gibson sketched the formation from memory. Aviation experts later noted that the proportions matched hypersonic design principles and suggested significant internal fuel capacity. If that sighting was accurate, Aurora was already operational by the late 1980s. The timing fits. By then, the SR-71 Blackbird had flown thousands of reconnaissance missions without ever being intercepted, despite hundreds, possibly thousands of missiles fired at it. None hit, but air defenses were evolving. The Soviet MiG-31 Foxhound could reach extreme speeds at very high altitude. Advanced surface-to-air missiles pushed engagement envelopes closer to the Blackbird's limits. Intelligence assessments warned that speed alone might no longer guarantee survival. The US needed something faster, higher, untouchable. Satellites weren't enough. They followed predictable orbits. Adversaries could simply wait until they passed. A hypersonic aircraft could appear anywhere on Earth without warning, collect intelligence, and disappear before defenses could respond. The most likely contractor was Lockheed Martin's Skunk Works. They had already explored Mach 6 concepts during the SR-71 program, shelved only because technology wasn't ready. By the 1980s, much of it was. At hypersonic speeds, heat becomes the true enemy. At Mach 6, surface temperatures can exceed 1,500 degrees Fahrenheit, enough to weaken metals and destroy electronics. The solution is to turn fuel into a heat sink, circulating it through the airframe to absorb thermal energy before combustion. This regenerative cooling system is complex, but it allows sustained hypersonic flight. Aurora likely relied on hybrid turbo ramjet engines, using turbojets for takeoff and acceleration before transitioning to ramjet mode at cruise. The aircraft would have been massive, fuel-heavy, and likely crewed by 2 people relying almost entirely on sensors rather than windows. At those speeds, even communication becomes difficult. Ionized air can disrupt radio signals, requiring specialized systems to maintain contact. Over time, Aurora faded from whispered rumor into aviation myth. Sightings became rarer. Budget trails vanished. Some believed the program was canceled. Others believed it simply went deeper into the black world. Then in 2017, a senior skunkworks executive publicly acknowledged that hypersonic aircraft development had matured and that a Mach 6 platform was moving toward flight. He didn't mention Aurora, he mentioned the SR-72. Its stated capabilities mirrored Aurora's rumored performance almost exactly. Whether the SR-72 is the public successor to a decades-old black program, or whether Aurora was something else entirely, remains unknown, and perhaps that's the point. Black programs remain black until they don't. The F-117 flew for years before being acknowledged. The B-2 was operational long before its capabilities were revealed. Even the SR-71 was once dismissed as fantasy. Aurora may be the same, or it may be something even more remarkable. The sonic booms were recorded, the sightings documented, the engineering feasible, the strategic need undeniable. The only question that remains is whether we're willing to believe that America built the impossible and flew it before anyone noticed.